The James Webb Telescope has amazed the world again. It discovered a galaxy so ancient that it began to change our understanding of the universe. With this finding, much could change. To understand why, let's return not to the dawn of time, but to the year 2022. Until this time, the most distant galaxy we had ever seen was GNZ 11, discovered by the Hubble Space Telescope. This was a significant discovery. Hubble, with its 2.5-meter mirror and incredible optics, deepened our understanding of the cosmos. However, he had limitations in the range of his observations. Then the James Webb Telescope was launched, equipped with a huge mirror 6.5 meters in diameter, and tuned to the infrared range, the very type of stretched ancient light emitted by early galaxies. Webb not only continued Hubble's work but broke all its records. In one of its first campaigns, JWST discovered a galaxy named Jade's GSZAO 140, setting the record for the most distant confirmed galaxy with a redshift of 14.32. Redshift, in brief, shows how much light from a galaxy has been stretched due to the expansion of the universe. The higher the redshift, the older the light. Then came the galaxy MOMZ 14 with a redshift of 14.44. It deepened our gaze even further into the past. But the scientists were astonished not only by the redshift, but also by how this galaxy truly looked. It is tiny, only about 500 light-years wide. In comparison, our Milky Way galaxy stretches over 100,000 light-years, but MOMZ 14 is also incredibly bright. Usually, galaxies from such an early period in the universe should be dim and hard to observe, but not this one. MOMZ 14 is full of newborn stars, a rapidly developing stellar cradle on the first pages of cosmic history. However, one feature, or rather the absence of one, makes it even more unusual. There are no signs of a supermassive black hole. Most galaxies with intense star formation have supermassive black holes at their center. These black holes are believed to play a key role in the evolution of galaxies, regulating star birth, shaping structure, and promoting growth. But in MOMZ 14, this is absent. The mysteries do not end there. When astronomers used the JWST spectrograph to analyze the light of a galaxy, they found it to be rich in nitrogen, unusually so. This chemical signature matches what we observe in some of the oldest star clusters orbiting the Milky Way. It suggests that MOMZ 14 forms stars in extremely dense conditions. This is not what we expected. Galaxies from such an early time in the universe should be chemically simple, mostly consisting of hydrogen and helium. But MOMZ 14 indicates that several generations of stars existed and died before its formation. This means that galaxy evolution could have started much earlier than we thought. This raises a big question. How many more galaxies like MOMZ 14 exist in space? Before the arrival of JWST, we thought that such early galaxies would be incredibly rare, but now we have found more of them than expected. These ancient bright galaxies, sometimes called small red dots, appear in all JWST surveys. Astronomers currently believe that the galaxy MOMZ 14 may become a record holder, but this could change soon. And this is where the most interesting part begins. The more we explore, the more we find. Each new discovery undermines our assumptions. If galaxies like MOMZ 14 existed in greater numbers, formed stars faster, and were chemically richer than we thought, what else are we missing? Does this galaxy challenge our cosmological models? Overall, yes. Our current understanding of galaxy formation asserts that such galaxies should be rare, slowly growing, and simple. But MOMZ 14 does not meet these criteria. It is fast, bright, and chemically complex. The issue is not that our models are wrong, but that they are incomplete. MOMZ 14 is a hint that the early universe may have been much more active than we imagine, and this is just the beginning. Later in this decade, the Nancy Grace Roman Space Telescope will join JWST to study the early universe. The telescope will be able to cover much larger areas of the sky with incredible detail. Together, these telescopes can reveal hundreds, possibly thousands of galaxies like MOMZ 14. Each one is a time capsule from an era we are just beginning to understand. But for now, MOMZ 14 remains an important milestone. This is a glimpse of light from the time when the universe was just beginning to form. However, the deeper we delve into the JWST data, the more the universe contradicts our expectations. Some scientists, interpreting the data, proposed a bold hypothesis that our entire universe might be inside a black hole. New research revealed an intriguing mystery. Most galaxies seem to rotate in one direction. The lines formed by peaks allow us to determine the direction of the curvature of galaxy arms and, consequently, their rotation direction. This is important because, in a truly random universe, galaxy rotations should be roughly evenly distributed between two directions. According to the authors of the study, this unexpected finding, which contradicts existing cosmological models, may suggest that our universe is inside a black hole. To understand this, one must consider the physics of black holes. When matter collapses under the force of gravity, forming a black hole, an event horizon is created, a boundary beyond which nothing can escape, not even light. Everything that crosses this boundary is forever lost to the external observer. Nevertheless, what happens within the event horizon remains a mystery. Here, black hole cosmology emerges. Also known as Schwarzschild cosmology, it suggests that our observable universe may actually be the interior of a black hole in a larger parent universe. Now remember the Big Bang. The standard model states that the universe began as a singularity, a point of infinite density, like the center of a black hole. If our universe is actually the inner space of a black hole formed in a larger parent universe, it would mean that the Big Bang was not an explosion in emptiness, but a moment when matter collapsed into a black hole, creating a new universe inside. This also has another important consequence. Each black hole in our universe could be a door to another infant universe. This could explain why the fundamental constants of nature seem fine-tuned for life, as black holes creating stable universes may have a better chance of surviving and reproducing in this process. Scientists believe this idea may shed light on several cosmic mysteries. For example, it is known that black holes have immense entropy, corresponding to the colossal amount of information contained in our universe. Another factor that may play a role in this theory is torsion. In extended theories of general relativity, such as the Einstein-Cartan relativistic theory, torsion is a property that accounts for the internal spin of particles and can influence the curvature of spacetime. Some theories suggest that this effect of twisting spacetime may create a repulsive force at extremely high densities, potentially preventing the formation of singularities. If this is true, it could mean that instead of collapsing into an infinitely small point, a black hole might experience a great rebound when its core bounces back and expands, potentially giving rise to a new universe inside. Scientists added that the rapid rebound after such a large bounce could have led to the expansion of our universe, an event we now call the Big Bang. Instead of the singularity exploding from nothing, it could have been a rebirth from the core of a black hole in the parent universe. This theory would radically change our understanding of cosmic origins, suggesting that the cycle of universes is a continuing self-reproducing process. Another intriguing possibility is that our universe may have a preferred axis. Research on large cosmic structures suggests a certain alignment in the distribution and movement of galaxies, rather than complete randomness. The so-called cosmic anisotropy challenges the widely accepted cosmological principle, which assumes that the universe is isotropic and homogeneous on large scales. If the universe indeed has a preferred direction, it may indicate unknown physical processes, possibly related to how our universe formed inside a black hole, or how fundamental forces interact on the largest scales. Moreover, the existence of ancient massive galaxies that emerged shortly after the Big Bang calls into question our understanding of cosmic evolution. Although the theory of a universe inside a black hole is exciting, there may be a more down-to-earth explanation for unexpected observations. Perhaps some previous measurements of our universe are incorrect, especially the speed at which the Milky Way galaxy rotates. In any case, the universe turns out to be much stranger than we could ever imagine, and uneven galactic rotations will likely force astrophysicists to reconsider some aspects of our understanding of the universe. What do you think about this? Share your thoughts in the comments.